Hi children, now let's continue with the chapter cubes and cube root in part 2. And we started with what is cubes. Okay, now let us see some interesting patterns in cubes. See, 1 cube is equal to 1 just from right to left. Then 2 cube is 8 and it is written as 3 plus 5. Then 3 cube is 27. 3 3s are 9. 9 3s are 27. Students make error by multiplying 3 3s are 9. It's wrong, my dear children. You have to multiply this 3 times. 3 into 3 into 3. That's how we got 27. And it is written as a sum of 7, 9 and 11. Next 13, 15, 17, 19. Then 21, 23, 25, 27, 29. Are you able to see the pattern here? What pattern does it follow? All these are odd numbers starting from 1. Then how many odd numbers I have here? 3 and 5. Then 7, 9, 11. 3 odd numbers are there. So 3 cube. Then 4 odd numbers are there. 13, 15, 17 and 19. So can you write 6 cube, 7 cube, 8 cube, 9 cube, 10 cube? Yes, we can write. This is an interesting pattern. That's what I said. We can see beauty in numbers. Okay. So this 6 cube is written as 31 to 41. How many numbers are here? 1, 2, 3, 4, 5, 6. Okay. Then 7 cube. 49. See the beauty. 6 cube. 6 square is 36. It lies between 35 and 36. And all other numbers are here. And similarly here. 7 squared is 49. It lies in the center. Then I go from the back order. Okay, 47, 45, 43. Then here 51, 53, 55 till I get 7 numbers. Okay, all these are, if it is an even 6 cube, I will have 6 numbers only. No, I will not have any extra numbers here in between. Here it is 7. So this is an extra number. Here 3 number, here 3 number. And what is 8 8s are 64. But it is not an odd number. So what is the next number? Previous number 63 and 65. These are preceding and succeeding number of 64. And here with this in mind, I have to complete even number of numbers to the left hand side and right hand side. See, here I have 3 numbers. Here I have 167, 69, 71. 3 numbers. Likewise, you will be capable of finding the cube as the sum of odd numbers. So you should be capable of writing for 9 cube. Okay, 10 cube. Did you understand what I mean now? If it is 64 even number and it is not an odd number, I have to write preceding and succeeding number first. Just because I have 8 here, I have written 2 numbers here. Then how many remaining numbers I should write? 6 numbers I should write. I have to write 3 numbers in the front and 3 numbers at the back. That's how I get the answer. Is it clear, my dear children? I repeat for 7 cube. What is 7 squared? 49. And 7 is an odd number. Okay, so I should have 7 odd numbers here. 1, 2, 3, 4, 5, 6, 7 odd numbers. I located 49 in the center. So remaining how many numbers? 6 numbers. That will be placed on either side of 49. Left hand side as well as on the right hand side of 49. Is it clear? All these are odd numbers, my dear children. This is how you should write cubes as the sum of odd numbers. Practice well for objective questions. Okay. Now, difference of 2 consecutive cubes. Again, we will see a pattern here. See here, 1 cube and 2 cube. Consecutive cubes means bigger number should come first. So we write 2 cube minus 1 cube. Now 3 cube minus 2 cube. 4 cube minus 3 cube. This is how we will get it. Difference of 2 consecutive cubes. 1 and 2 are 1 cube and 2 cube are consecutive cubes. 2 cube and 3 cube are consecutive cubes. Similarly, we will get 5 cube minus 4 cube, 16 cube minus 15 cube, 101 cube minus 100 cube. You will get it. Okay. If I observe this pattern, what do I see here? Everywhere I have the first number as 1. Then plus. Then at last I have 3. This 3 cube. What is done in between? I am finding cube of 2 consecutive numbers, no? Their product. 2 into 1 into 3. Again start with 1 plus. Then 3 into 2 into this 3. Then again 1 plus 4. This is the number here. 4 into 3 into 3. This 3 is fixed for all. And this is also fixed for all. Only this is product of the 2 consecutive numbers for which I am finding the cubes and then finding the difference. Is it clear, my dear children? Are you all able to understand this pattern here? Always 1 plus. At last into 3 only. In between, I have 2 into 1, the product of the numbers. See now, multiply and see. As per Bodmer's rule, I should do the multiplication, then addition. So 2 3s are 6. 6 plus 1, 7. What is 2 cube? 2 into 2 into 2, 8. 8 minus 1, again 7. Here I get 7, here also I get 7. Is it clear? Now I will explain you one more thing. Here I have 3 cube. What is 3 cube? 3 3s are 9, 9 3s are 27. What is 2 cube? 2 2s are 4, 4 2s are 8. Not 3 2s are 6, my dear children. Again be careful with this. Not 2 3s are 6. 2 into 2 into 2. You have to multiply 3 times. Not 3 into 2. 2 into 2 into 2. So 27 minus 8. Now what should I do here? Multiply this. 3 2s are 6. 6 3s are 18. Again 18 plus 1. 18 plus 1. 19. I get 19. Even if I subtract 27 and 8, I get 19. Is it clear, my dear children? So, this is how we used to find the difference in cubes of 2 consecutive numbers. Special condition, they should be consecutive numbers. Okay, children. Now, shall we move to the next? And you are going to try now. It's your turn. Now, try it. I have 20 cube minus 19 cube. How to begin with? Always 1 plus. Again, what are the numbers I have? 20 into 19 into 3. Is it clear? Yes, 1 plus 20 into 19 into 3. So, multiply all these 3 things. Instead of multiplying 19 into 19 into 19, again finding 20 into 20 into 20. This of course easy and this is little bit tough. And again subtracting. It will be a long process. But if I use this property, it makes my calculation simpler and easier. Okay. So what do I get if I multiply all these 3 numbers? I get 1 plus 1140. So what will be my answer? 1141. Again one more try. 51 cube minus 50 cube. What is the first thing I should do? It is about cubes, my dear children. 1 plus 51 into 50 into 3. Is it clear? Multiply 51 into 50 into 3. What do you get? 7650. If I add 1 along with that, I get 7651. Isn't this calculation simpler and easier? Instead of multiplying 51 3 times. And if you think about it, something a bigger number, it will be very tough now. So these properties helps us to make our work simpler and easier. Okay, now let's look at difference of 2 consecutive squares. Just now we saw difference of 2 consecutive cubes. Now in the chapter of cubes, I want you all people to recall difference of 2 consecutive squares. I gave this in recent worksheet also. What is the formula? 2n plus 1. If it is 32 here you will have 33. 32 plus 1, 33. Is it clear, my dear children? What is the formula to find the difference of two consecutive square? It is 2n plus 1. Make it clear, 2n plus 1. So here is our examples. 32 square, not cube. 32 square minus 31 squared. So it is n plus 1. 31 plus 1 is 32. 2 into 31. This is n, my dear children. Again you will make an error by substituting n to be 32. It will be wrong. See, 2 into n. n is 31. 2 into 31 plus 1. 2 31s are 63. Sorry, 62. 62 plus 1, 63. Is it clear, my dear children? Now again, if I take one more example, 109 minus 108. What is n? 108. 2 into 108, 216. 216 plus 1, 217. Is it clear, my dear children, how to find the difference of two consecutive square numbers? See here, I am going to show you another one more thing. Number of non-perfect square. There is a link between this concept and the previous concept. Number of non-perfect square. And you should not get confused with these two things. There are 2n non-perfect square numbers. The difference between these two is 2n plus 1. If I ask you to find the number of non-perfect square, you should write only 2n. Okay, there is a link between these two properties. Let it be a recall for your exam, my dear children. Don't get confused with these two things. If they ask you to find the difference between two consecutive square numbers, it is 2n plus 1. If they ask you to find number of non-perfect square, you should find only 2n alone. Is it clear, my dear children? Shall we try with one more example? Here it is. Find the number of non-perfect square numbers between 32 squared minus 31 squared. And again the answer is 2n alone, my dear children. There are 2n non-perfect square numbers. So 2 into 31. n is this 31 and not 32. Repeatedly I am making this note. Be careful. 2 into 31 is 62. So there are 62 non-perfect square numbers between 32 squared and 31 squared. Is it clear, my dear children? Okay. Now let us look at come back to cubes. Cubes and their prime factors. We all know to do prime factorization. And they have done the prime factorization for 64, 216, 15 cube, 12 cube. For all these, see here, for 4 I have 2 2's. If it is 4 cube, how many times it is written? 3 times. So, 2 2's together. This is 4, no? 1 4. Then another 4. Then another 4. Is it clear, my dear children? So, 4 cube is 4 into 4 into 4 and it can be again split into 2 into 2 into 2 into 2. See, now club them into triplets. In squares, we will club them into doubles, twins, and here triplets. 3 2's together. So, this 2 fully together 2 cube and this fully together 2 cube. Is it clear? Now again look at the prime factorization of 216. 3 2's and this 3. 2 is occurring in triplet and 3 is also occurring in triplet. And here 3 in triplet, 5 also in triplet. 3 power 3, 5 power 3. Here 1728. How to get all these numbers? Just again simple prime factorization that we have practiced right from standard 4 or 5. Okay. So prime factorization method only. Start from 2 and continue whichever table you get in prime numbers. Okay, so we get 2 cube into 3 cube. Is it clear, my dear children? Okay, now let us see whether it's a perfect cube or not. To check 216 is a perfect cube or not. By prime factorization method. See, this is how you should do prime factorization method. You already know this. So 5 2's are 1 2's are 2. Again 0, 8 2's are 16. You know this. So I got all these factors here. Everything is occurring in triplet. If it is occurring in triplet, then it is a perfect cube number. 216 is a perfect cube number. What do I have done in these two steps? I have clubbed 2 into 3 under one single power. Okay, this 2. See, you will learn all these things in exponents chapter. Okay, now have a think that this 2 and 3 are both are repeated 3 times. So I will multiply them and then repeat it. So 6 cube. So it is written as 6 cube and 216 is a perfect cube. So is 243 a perfect cube? If I find the prime factorization. No, it is not occurring in triplets. This last three numbers, last two, this is not occurring in